Manufacturing Matters is an MFG Radio Network production brought to you by GIE Media's Manufacturing Group as industry experts take deep dives into the latest manufacturing matters, whether it's new innovations, products, technologies, and emerging markets that help you understand better why manufacturing matters to you and also to the top companies in the medical, aerospace, defense, and electric vehicle manufacturing industries. Hello and welcome to our latest discussion from GIE Media's Manufacturing Group of magazines, Automation Implementation with System Integrators. I'm Jake Kaufman, the Managing Editor for Aerospace Manufacturing and Design, Defense and Munitions, Today's Medical Developments, and our online publication, EV Design and Manufacturing. Very glad to be joined today by Fastems. Fastems is the leading supplier of flexible automation solutions for high-mix CNC manufacturing. Representing Fastems today is Christopher Resny, their U.S. Central Regional Sales Manager. Resny has worked with fabricating and metal cutting OEMs, as well as spindle manufacturers and software developers throughout his entire career. Since joining Fastems in 2020, Resny has shared his experience with manufacturers wishing to adopt fully automated systems into their operations, helping them get the most out of their CNC machining centers and other equipment. Resny holds an MBA from Loyola University in Chicago and has earned CMTSE accreditation. So without further ado, Christopher, welcome on in. Thank you for joining us today.
Hi, Jake. Thank you very much for having me.
No problem. So I want to get right to the discussion and ask, where in the manufacturing cycle is automation being predominantly used in the industry today?
Okay. Sorry, I have a lot of notes here, so I have to, some of it's up in here and some of it I've got to seriously rely on some notes that I've over the last few days preparing. But you know, with automation, at least in the realm that we participate in, that I'm more familiar with, has been in not only in the metal cutting, but in the ancillary operations that go together with metal cutting on a manufacturing floor. Now that being said, there's assembly manufacturing for automation, fill for whether it be pharmaceutical, whether it be food and beverage. But I'm going to try to just steer this towards the playground that I'm in, day in and day out. But so prevalently, it's the manufacturing floor and most commonly a metal cutting floor, whether that's churning the parts or milling parts, grinding parts, even deburring parts, automated deburring, to take that operation essentially out of what the cycle time is, so a machine tool can actually be cutting more chips and essentially maybe making the cycle time a little bit faster. But so besides that, you have production. We mentioned, I touched a little bit on assembly. There's also material handling and automation, and whether that's getting a part from point A to point B. But again, going back to the arena that Fastems is in, that is something that we can even incorporate into an automation system. And a good example is part ABC, where it's a raw material, but that raw material can now be made into 15, 16, 25 different parts, depending on the operations. Keeping that raw material internal to the system and having the system bring down that material at the same time that it brings down what the fixture is on what pallet, knowing where that program is, knowing what machine is going to do the next operation, but having that material come down at the same time so that the operator can take that material out of the bin, put that material now on the fixture for whatever that program is in the schedule for it to go on to its next step. But with that automation also becomes, it has that digital footprint. There's a lot of other information that is also being passed around. So bringing that material down, right now it's inventory, but as soon as taking it out of inventory, putting it on that fixture to get machined, now becomes part of WIP.
Mhm.
And we have that ability to automatically update if it's coming from a shop floor ERP system to an SAP system, which is with the file transfer to automatically let that system know instantaneously that that is now going into work in process, updating minimums and maximums, whatever they may be for that material, and sending those signals on down to the supply chain so other decisions can be made. So automation, it's a lot more, and you and I had discussed this in the past, so I apologize going through the same repetitive example, but it's, there's a lot of companies that can do this and move a part around from point A to point B. And again, whether it's something in the pharmaceutical industry or food and beverage getting filled, that's getting moved around. Or, or part going into a loader with a simple load and go robot. That there's many companies that do that, but it's also the communication and the data and the programming logic behind it, and where that can also add value down the line.
Awesome. Thank you, Chris. So this is also something that I had talked about with our different publications. We have aerospace, we have a medical, we also have defense, and also an EV publication online. So out of those four industries, whether it be medical, aerospace, defense, or the EV/automobile industries, which one of those would you say has really embraced automation and is using it, at the fullest extent at the moment?
Automation in its infancy, when you talk about that, you can't help but talk about the automotive side and what was developed with, what was known as heart tool transfer lines that then became a little bit more flexible. But more recently, besides that, on the EV side, we've seen that yes, there are maybe not directly with some of the EV manufacturers, even though there are, but also with some of their large subcontractors, and more on the battery side, whether that's the battery, the casing itself, or what is actually going to be holding the modular device that's actually to be holding that, depending on if the vehicle's got 6 wheels, 8 wheels, or 4 wheels, or 3 wheels. But beyond the automotive side, I would say it's, definitely there is medical for medical componentry, as well as the medical device manufacturing, and the prevalence that was, especially during COVID. We had a number of our customers who were very large. A good majority of our customers are very large general contracting companies. So, and they do service into the defense, into the aerospace, and into the medical. But if you remember during the COVID pandemic with the ventilators, we did have a number of end users that were able to seamlessly transfer over and use their automated system and rededicate some of their tooling to start making ventilator components, and they didn't lose a step. So I would say it's been prevalent in all of those industries, but what really, really helps and what the huge benefit is in the adaptability of that automation and how quick new programs, new tooling can be introduced and into the scheduling can be interjected, based on what the needs are and what the priorities are to now start to process those new parts. And I'm just happy to say I know that is one part of the automation side that Fastems has really, really captured. And again, just myself, I was able to see a lot of that firsthand.
Awesome. Thank you, Chris. So obviously another impact of the COVID pandemic was the loss of workforce at some of these factories. So how has automation been able to make up for the loss of workforce and even make the workforce that is in place more efficient?
It's doing more with less.
Hmm.
And if you could see, here, hold on, let's bring up my, again, I'm sorry for the shameless plug here, but if you see the 8760, that's, what that represents is 365 times 24. That's the potential for any machine on anybody's floor to actually be producing parts or maybe not producing parts, but let's just say operating and removing the material that it's intended to remove. That's the only time that asset is going to be giving some sort of an ROI
Mhm.
to the end user. So now take that back, and down to the crux level of your question of doing more with less. That is really where automation kicked in. There were many companies that, and in all diverse industries, where there were substantial labor reductions because of supply chain and necessities and what happened during the implications of the pandemic. We've had some users that, again, going back to your first question, where I mentioned seamlessly went into the ventilator side. They
Mhm.
were able to reallocate resources, and they may have lost that third shift, but it's the scheduling and the capability for that automation to operate unattended that became a necessity. I mean, by design, that's what automation can do. You can get those overnight hours where maybe you don't have somebody on shift, or you can get those weekend hours. Maybe a company, it basically staffs 4 10-hour shifts 4 days a week, or 5 10-hour shifts, or 5 8-hour shifts, but they leave that weekend wide open. Doing the planning, taking a look at components that may have a longer runtime and running those during those by design unmanned hours, you're taking advantage of those unmanned hours. You can get, out of that 8760, if you take away a third shift, you cut that by a third. If you take out a weekend, you're cutting that again by almost another 2,000 hours. What you can do with those hours as far as scheduling out components, having the resources ready, and
Mhm.
having the machines capable, and having the data to capture as well as the software to monitor, now you can take care of that. But a lot of companies have had to make that adjustment. There's not, and again, in a past conversation you and I had, there's not those thousands of younger talent that want to say, holy cow, put me to work on a grimy floor. I want to smell like coolant. I want to have chips embedded in my jeans and in my boots. And I would love to work in 95-degree environments with the doors open. That's not happening anymore. So companies that are in that environment, that have to produce parts, have to be able to be nimble enough to do
Mhm.
more with less.
Awesome. Thank you, Chris. So then the next question, you had mentioned data at the very end there, kind of leading the witness to the next question here is
Yes.
how data driven are the current automation systems? What is that data being used for? And, how do you use it to your benefit?
Yeah. The best way to describe data is, um, it's depending on what side of the table you're on, it's a necessity, but there's also ways to harness it. Yeah, the data is there. There is data to capture. And depending on the software that you have, capturing that data can lead to better accuracies. It can lead to better consistencies. It can lead to on-time deliveries. It can lead to better throughput. The data is there to capture, to make the end user better and more adaptable. And as long as and if the system is scalable enough to adapt to that data, whether it be uptime, machine utilization, everybody likes to look at cycle time, but then it comes down to throughput, and then there's the data on, I mentioned accuracy and consistency. Instead of having to take a part off of a fixture and put it on a forklift or carry it to the CMM room, which may be across the facility. And now that part also may be unclamped. So all depends on the nature and the design and the material. I'm painting with a broad brush here, but now you have that ability to have that operation in the same system as you just did the metal cutting, whether a part has to relax, whether it goes through an automatic, there's machine and then it goes through an automatic weld, and then it has to relax, and then it gets washed, and then it goes through a CMM. That can all be encapsulated in a living system right now. So in having that data, and that data may be necessary depending on, if you're in the medical community and if you have to go through audits and if you have to give your weekly and your monthly reports or you're ITAR compliant and now you have to give those reports. It's necessary to capture that data, and software has increased to the point that we're able to do that and capture that in real time and not have that have a dwell.
Awesome. Thank you, Chris. So then what are some of the benefits of automating when it comes to quality control and inspection during manufacturing?
Oh boy, you just did a layup question for me because I kind of crossed over with that last answer, but having that all inside a system, having in depending on the necessities and the accuracies of the part, and being able to capture that real time, having that CMM inline and having that be part of the process when you take it out of machine A for say an op 10, a machine 20, machine 2 for op 20 or what have you, and then it goes directly into the CMM. Now you're measuring it in its environment and having that data to trace back. There's traceability aspects also. Even if that doesn't happen and that CMM capability has to take place offline, there's ways with software to have traceability, to designate exactly when was that part machine, what program, at what time, at what tools, and capture if there's an error, being able to bring that down to the least common denominator. So now you have that error and you're able to subtract it, correct it, and now you start making better parts. So, in regards to, it's an active system, and having that system be active with the correct software. Once you know what everything is, and this is on the designability and the scalability of a system on the front end, but knowing if that's what an end user really needs to capture, there are ways where it can be absolutely organically put into that system.
Awesome. And it's also not like, Chuck on the assembly line has to check out every single part now. He does have a backup essentially.
Exactly. From simplistic go, no go gauges to Chuck, measure that right here. That's and just that's how I learned. I was introduced to machine. I had an uncle who has a machine shop. My cousins run it now, and very successfully. But there were times in high school and summers during college where I would go and I would help him out on a Saturday. And basically that part would come out of his old machining center. And he would say, okay, Chris, here's a caliper. Here's measure this, measure that. And you're able to set the little indicator. If it goes beyond that, call me. And he would come out and that was the simplistic way of, automatic feedback if something was out of tolerance. And
Yeah.
Call your uncle. But so going from that to what a system is capable of doing now, it's extraordinary.
Awesome. Thank you, Chris. So if a new client wants to enter into automation, what are some things that they have to have in place before they get up and running?
Boy, they have to really have a plan. And it has to be shared. It has to be shared. Again, what a company needs to do, or at least, and I'm not here to tell people what you have to do, but from what I've seen, the best adaptions of automation are when a company has a plan, they get their employees to buy in, they pair up with a very good integrator, somebody who could share their focus and has enough of a history to say, okay, we've done this before, we've done this before, we've done this before. So it has to be a reputable integrator, and then share the plan with that integrator. And through that process, you also will develop who your champion is going to be inside that company. Somebody has to take ownership. Just putting an automation system or something that's, whether it's, automated to the nth degree or just simple automation, even if it's something as simple as a pallet pool from an OEM, where it's just, it has to have a buy-in, because it can't be looked at as a threat.
Mhm.
It's here to replace people. There has to be a buy-in where the people who actually utilize it and implement it internally in the company understand what the end result is going to be. If it's force-fed to the people on the shop floor, it is automatically a recipe for failure. It just won't work because either there'll be just a grillion excuses, or it'll
Mhm.
get absolutely ignored. And I'll use an example again, but I think it's kind of glaring because it emphasizes your point exactly. There was a contract manufacturer that we ended up working with and getting a system. But when I first met them, the owner of the company sat me down and he said, "How do you know this is good? How can you guarantee me this will be a success?" And I said, I can't. And I said, what fears do you have? He said, well, we put a robot in, we put it in between two lathes at one time. And it was supposed to be a chunking application. And within 6 weeks, that robot was deactivated and there were bar feeders on the machine. And now those are bar feeders. How do I know that's not going to happen? And again, I had to, just be, and it's one of those, okay, here's a trick question and how honest do you really want to be?
Mhm.
And I think I was very honest in saying, listen, that comes from the vision. If you're the owner
Mhm.
of the company, it's your vision and you have to carry that vision down and get people to buy in. Because
Mhm.
if you just set it down and you don't have them buy into what that vision is, they will find a way to get around it or do something else. So you,
Mhm.
you can't automatically say automation is the solution and it's going to solve all your ills and it's going to tuck you in at night, make you sleep well. It's all about the plan and the buy-in and the rollout and having that vision understood.
Yeah,
So
it's from the top
that's
floor to the shop floor.
abs beautiful. I'll use that again sometime,
Oh,
but I'll give you
perfect.
credit.
Believe me, I think I have stolen it from three different people. So, so
So,
then, Chris, if we were talking about a customer that is existing and has an automation process in place, how do you kind of, coach them through an expansion? How do you kind of decide when it is the right time to add more automation to the whole process?
and again, that's all case
Mhm.
specific, but when it comes time for that, just giving examples, and that's where you have to have a really good open relationship with the people who are planning. You're doing this generation of part A, and that's wonderful. How do we adapt this in the future? Your part A um, has a life of 3 years before you already have revisions on the board. Help us look at those revisions and, oh, you might need to add that. You know, that's when a system becomes scalable. And having a system that is able to be expanded is key. And it may not be. It may be that there are, whether it's length designations inside a facility, excuse me, that have to be taken into account. Maybe it's a duplicate system that has to be there. But um, so how do you coach them through? I guess it's having that relationship just to know, again, what's your plan?
Mhm.
Have us be part of that. Um, and it's not a one size fits all. Yeah, and the part may look absolutely similar, but now there's other designations. And okay, let's use the welding, for example. Maybe the
Mhm.
first generation of parts didn't need to be welded. The second generation of part needs an automatic welding. It's going to take too long before they take it again, when maybe that welding is being done by an outside vendor. How do you bring that in-house? Let's automate that and make that one of the stations either in this current system or in this next system to be able to do that. So it's having and here comes the shameless plug for Fastems again. Uh, Fastems has been doing this for 42 years. So there's over 5,000 installations worldwide. And so if there's 5,000 installations worldwide, odds are they have looked at 100,000 different applications in 42 years, knowing what will work, knowing what doesn't work, and knowing how to get that information to the current end user. So you have that background. You have installations that you can rely on. That's really, I would say, the biggest thing is having that background historical information where you can really lead somebody through and say, I know you think you're alone on an island and doing this all by yourself, but let me tell you this story. Let me have you contact them. This is what they went through. And it was very, very, you're going to realize it's like an 80-20. 80% of what you guys are going through, you have in common, and they were able to solve it. So it's not, nothing is really insurmountable. It's just, it just takes time to understand it.
Awesome. Thank you, Chris. So then the next question is, if these adjustments and changes have to be made to an automation system, how easy is it to stop and then get it back up and running once those changes have been made?
Boy, a lot of it, to stop it, and it's never easy to stop. But again, if the software needs to be updated, if there's something on the software side they can address whatever change needs to be, or quite possibly having the ability to take a look at what they're trying to do and do a simulation of it. That's one huge way to take a look at, is this even possible, or will this even work? How much time is going to be allocated to, this part has to come up, but now this part also has to be twisted and flipped before it goes into the next operation. How do you do that? Before you spend a dime, it's good to at least define the process, take it through, and if there's ability to do some simulation of it, look at the simulation, dissect it, provide that information, have a good discussion and feedback, and realize what the scalability of either the current system is, or again, maybe that's not adaptable with what we have here, but here's how that can be done. And there's got to be in another system next to it. So there are ways to dissect it, whether it's through just planning, and again, going back to having some historical information about, has this been done before? Have we seen this before? That constantly comes up with, is this challenge acceptable, or do we have to raise the white flag and go, man, that's not in our realm? Yeah. And some of it also comes down to, again, in the metal cutting side, cycle time. If a part is coming through and it's got a cycle time of 16 seconds, you're going to have an issue. You're going to have an issue when it comes to unloading that part repetitively and having parts back up. So how do you marry parts together? How do you marry in operations together? How do you get that throughput and maybe absorb that 16 seconds in another operation? So now that operation is sustainable, where you're not going to artificially create a bottleneck or a problem.
Okay. So then this obviously too would depend on what the change is that's being made, but are there systems out there that would continue running while you make these changes? Or is it something where you would have to, like I said, shut it down in order to make the change?
Oh, no, absolutely. You can keep the system running. You can designate in, on one of our systems, if you've got multiple machines, you can quarantine a machine or isolate it and have those first article, second article tested out while the rest of the system is having scheduled throughput. So yes, do you risk, okay, maybe some of your efficiency is going down because you took a machine offline? Absolutely. But are you still getting, you say, an example is a 6-machine system, you still have 5 spindles running and chucking and cutting metal while you are doing whatever testing you are to prove out, on machine number 1. So yes, that is all completely possible.
Okay, awesome. Thank you, Chris. So then with all of these new technologies and things like that being incorporated into the automated systems, what are some of the challenges that are being faced as far as hacking, the computer and connectivity issues, software updates, things of that nature? Like, what kind of are the outside threats to an automated system in a factory?
Wow. Yeah. Cyber attacks and ransomware, it is so prevalent. And it's, you turn on CNBC and you hear about cyber attacks, and it's usually an insurance company or a credit card company, as you and I
Mhm.
shared about, the recent experiences with
Yeah.
Chase. And oh my God, social security numbers of every known person alive or dead for the last 170 years have been released. It happens. There's a there was a uh, contract manufacturer recently here in the Midwest that we were in the middle of a project, and then um, started not getting some return phone calls for a while and was wondering what was happening. And it turned out that their whole shop floor got infected with ransomware. And it took almost 3 weeks for them to recover. And it was just paralyzing. Um,
Mhm.
it is the figures that I've seen, and this is just it floors me, that it was $80 billion in 2023 for the manufacturing sector was spent on cybersecurity, and the estimates by the end of this year are going to be $87 billion. $87 billion. I went through and I took a look. There are 121 countries in this world whose GDP is less than $87 billion. And that's what's being
Yeah.
spent domestically in the United States just for cybersecurity. For the manufacturing sector. So that
Mhm.
doesn't even take in the accounts and the insurance companies.
Yeah.
So it is something that is prevalent. It is something that needs to be guarded against. And essentially there's so many, which is what's also led to these restrictions, if you are,
Mhm.
depending on, and that you're more than familiar with on the aerospace side with ITAR, what you can and what you can't connect to the system, what you can and what you can't duplicate or transfer. There are
Mhm.
so many, at least safeguards that are trying to be created and put in every year that companies have to adapt to. And on the back end for again, for Fastems and for what we do, for as much of a hardware company as we are in coming up with automated solutions, we are also a software company.
Mhm.
We have over 150 software design engineers and application engineers that are constantly perfecting the software, but at the same time, looking for constant ways to protect the end users. And how do you put up those walls, and what can be transmitted and what can't be introduced? So yeah, unfortunately, it's an ugly thing that's out there, but you have to adapt to it and be prepared for it, because it's around and it's lurking in every document that you get in an email, and every document that gets transferred, every part print that you think is being identified before you do a click on a DXF, there could be something behind it.
Yeah, always got to be careful. Better to be too careful than not careful enough when it
Yeah.
comes to cyber attacks. So then, obviously, last thing we have to talk about is the future when it comes to
Yeah.
automation. What are some approaching technologies or some promise that you've seen that you're really looking forward to seeing get rolled out here
Yeah.
in the automation sector?
There's you can't turn on the TV or a news program without hearing about AI. And that's coming. And it's here right now.
Mhm.
As far as the automated intelligence and the thought process, and having controls start to think for themselves and make adjustments, make decisions, given to certain parameters, being able to make choices. The other side of that is the machine learning, the ML. I
Mhm.
think that's going to become, yeah, and they kind of go hand in hand, but making the machines more adaptable and having that data chain being able to make decisions and incorporate, tool 123 ABC isn't, tool 123 ABD is, and that's a better choice. Here's internally, here's what our speeds and feeds parameters are, and having those decisions being made and adjustments being made on the fly, that's going to be coming. It's a little
Mhm.
scary to think of that, but it's just the next step in the chain of evolution in what's going on a manufacturing floor. So I think those two and the ramifications from, looking at the secular application at a machine tool or on a coming off of a spindle to what are the implications to supply chain decisions that could be made, automatic orders coming through to know when inventory needs to be done. That's all going to start to be done. It's not going to phase out the human side. The human
Mhm.
side is still going to be there. They will have to monitor it, but eventually that's going to be the next step where it's going to be self-monitoring. So it's coming, Hal. So
In the
yeah,
near future,
near
before we even
future,
know.
yeah,
So
absolutely.
that just about wraps things up today, Christopher, and I appreciate your time. But if people do have questions for Fastems, where could they potentially reach out? Where would you guys potentially have these technologies on display coming up?
Okay, we will be at IMTS. So we are on the south floor, and boy, you would think I have that at my fingertips. I know I think it's 338-966. I will double check that if you give me 6 seconds.
If not,
You,
obviously the South Building, and
yeah,
you'll
we are
be
in the
able to
south
find
building of
Fastems.
IMTS. Um, we've been at, you can reach out, go to our website, www.fastems.com. You can reach out to me directly. And you see my name in the introduction. It's my email is very similar to the way my name is presented. It's Christopher.Resney@fastems.com. But our website has testimonials, it has videos, it has examples. Again, 42 years of capability and experience. The YouTube application has a number of videos, self-published by Fastems that are there, but also some testimonials and what we're able to discuss, based on disclosures with companies, but there's testimonial videos from some end users also about applications and from applications that you can hold in your hand to 30,000 kilogram parts that we have around the world that we're actually doing processing and automating for. That's the range of what Fastems can bring to the table.
Awesome. Well, Christopher, thank you so much for your time today. Thank you to Fastems for today's presentation. So once again, that is Christopher Resney, as you can find him at Fastems and coming up at IMTS in Chicago. Thank you so much, sir, for your time today, and I will see you at IMTS.
Thank you very much, Jake.
You can listen to all of our episodes of Manufacturing Matters and Lunch and Learn podcast from the MFG Radio Network on Spotify, Apple Music, and on our websites, todaysmedicaldevelopments.com, aerospacemanufacturinganddesign.com, defenseandmunitions.com, and evdesignandmanufacturing.com.